Hi friends, welcome to our channel. Let's have a look at problem 3341. Find minimum time to reach last room 1. In this video, we're going to use shortest path algorithm. So here I'm going to use Dijkstra's algorithm. Dijkstra's algorithm. So here, actually, I want to first mention that there are two main ingredients in Dijkstra's algorithm. So ingredients in the current implementation. One is a min heap. Another is relaxation. So if you can think of this as a graph, assume that you have the current distance arriving from the source to the node U is this one, and the current distance from V is like this. Then if there's an edge, it's called distance from U to V, right? So if the relaxation basically says that if this U plus DUV is less than this V, so we are going to update this V to be this part, because we find a shortest path by V of U, right? And then also we set the previous nodes. Let's see, previous nodes of V is U, right? So this is the relaxation. But in this problem, we don't need to retrieve the previous nodes, because if you retrieve all the nodes, you are going to get a valid shortest path. So this is basically the two main ingredients. Once you know this two part, I guess writing the code is just to encode the problem requirement. So here the problem requirement is the main thing is this. So we have a 2D array called move time, which basically represents the minimum time in seconds when you can start moving to that room. And also notice that the start time is we start from room 00, right, and t equals 0. And we can move to an adjacent room takes exactly 1 second, right? So in order to move to a room, nearby room or adjacent room. So if the current time is t, right, and then so here I change this move time to d just for ease of so the current time, the adjacent room, let's see, call it xy, right? The index. So then the minimum time to arrive at this room is nothing but the max t and this dxy plus 1, right? So this is the minimum time to arrive at this room at xy. So this will be our main concern, right? So once you notice this several parts, so the two ingredients in Dijkstra's algorithm, and this time for arriving at a room at xy, then you basically get the code. So here n is bounded above by 50 and m is bounded above also by 50, right? And also both m and n are greater than or equal to 2, and the move time is in this range. So I guess the problem set is not that large, right? So now I'm going to implement the Dijkstra's algorithm quickly. So first we want to have a distance. So dist I'm going to use collections default dict. So I'm going to map everything to be float infinity, right? So here we have a single source that is from room 0. So I'm going to set the room 0 corresponding to a value that is 0. So you can understand the value to be a distance or shortest time to arrive at the room, right? So basically it starts the room and the shortest time to arrive at that room. So this is the initialization for this. So here again, I'm going to also get this length of d and length of d naught. So this will be the n and m. I retrieve that just for convenience. So once we have this, so we actually can do the Dijkstra's algorithm. So here, let me first ignore to retrieve the the previous nodes, right? So let's first get the result right, and then we can comment on that. So here we have a heap. So initially, so you add 0. So the first component is time. The second one is the coordinates. So basically we are storing TRC, right? The position. So then basically you just need to do a while loop, while heap. So we get the time, the position, that is heap Q, heap pop, right? From this heap. And then if R equals n minus 1 and C equals m minus 1. In other words, we hit the bottom right corner. So we are going to return this T, right? And then otherwise we are going to check the neighbors. So for x, y in, so the four neighbors r minus 1, c, r plus 1, c, and r c minus 1, r c plus 1, right? So we hope that if x and y is inbound, so that is 0 less than x less than n, and 0 less than or equal to y less than m. And also we hope that this is not infinity, right? If it's infinity, it means I haven't visited yet. We hope it's not visited yet. So this xy is float infinity. Well, here you can use infinity, or you can use some large number. That will be okay. Have this one, and then this says that inbound and not visited yet. So we are going to do relaxation. So for doing relaxation is this: if max of t and dxy, because dxy is the minimum time to arrive at this, to start moving to this room, then plus 1, I guess. So if this guy is less than this xy, right? So then what do we do? So we do relaxation. So this is xy. It should be equal to this number. So once we've done this, so we're going to push this information, heap q, heap push. Let's see, push to this heap. What's the information? So the distance, that's this xy and x and y. So that's it actually, because we will always hit this one. So we always return at here. So let me run it. Yeah, it passes the 3 cases. Now let's look at the generic case. It passes all the cases. So here, as I mentioned, that we can also retrieve the previous nodes. So here, let me write a previous. So this is also dictionary collections, default, and dict. So lambda. So first, I'm going to map everything to be a none, right? So so once you do this relaxation, what you do? You can also add previous of xy will be set to be rc, right? And then you get this information. So actually, once you up to here, so you can print out the previous. So let's check the examples. Let's run it. So let me, yeah. So here, for example, this one, this is very special, right? So the so this is the destination. So the destination is from 0, 2, and 0, 2 is from 0, 1, and 0, 1 is from 0, 0. This is example case 2. For this one, actually, 1, 1 is from 0, 1, from this one, and then 0, 1 is from 0, 0. Similarly, you can do for example 1. Let me also check. So even I add this, still pass all the test cases, right? Let me submit that. Yeah. So I can comment out this part if you don't want to retrieve the previous. Yeah. If you want, you can just comment out or recover. So this will be a solution to this problem. You are welcome to try some other method, such as heuristic method or purely breadth first based method. That will be also a good, both are good practices. So with that said, I guess that's basically about it for the current video. So here I want to mention to you, we have a YouTube channel which contains more than 1,000 carefully prepared YouTube videos for you to practice. You are welcome to check out those videos. With that said, thank you for watching.